Saxon Algebra 2, Lesson 10. Students, today is a fun day. We're going to talk about the Pythagorean Theorem, which is a super useful tool and a fun little easy to remember dude. Before we jump into that, I want to give you just a little bit of background in theory. In math, we have a lot of rules. They go by different names though, which is confusing. Sometimes we call them properties, and sometimes we call them definitions. Those are just different types of rules. Whenever you hear those words, just think, oh, okay, it's a math rule. There's a third kind of rule that's called a theorem. That's the kind of rule we're talking about today. The thing about a theorem is that it can be proved. And by proved, I mean specifically shown to be true by using a geometric proof. Next year, we're going to get into doing geometric proofs, and you'll see what I mean by that. So that's what's special about the Pythagorean theorem, is that we can work through a step-by-step process and demonstrate that it is true. Math rules tell us the way things are. Properties and definitions we take at face value. Theorems we can actually prove. Okay, I use that word in a technical sense because we would use a geometric proof to prove it to be true. Okay, so that's why we use the word theorem, and that's why it looks kind of scary, but it's not. Okay. Oh, the Pythagorean theorem. You probably want to know what it is. Well, you always remember, right? Pythagorean theorem works only for right triangles. This is what we're looking for before we can apply the Pythagorean theorem. Right triangles only, right? And in order to apply the Pythagorean theorem, we have to know the difference between the hypotenuse of the triangle, which is the side that is opposite the right angle. And I always imagine it, if you can sort of visualize this as a complete rectangle, it's where we cut through with a pair of scissors to have a diagonal piece. That helps me imagine it, because I used to watch Captain Kangaroo. I don't know if you guys ever heard of it. It was a kid show, not unlike Mr. Rogers, where there was an actor who was pretending to be this dude named Captain Kangaroo who lived in a fun house and did all kinds of fun projects, and he had a lot of friends, some of which were human. What was his name? Mr. Green Jeans? Yeah. And then he had puppet friends too. And he used to do art projects on TV, and he would go very slowly and show you how to do it all. And he would take construction paper and he would cut it often in simple shapes, and his scissors made the most satisfying noise when it crunched through that heavy old school construction paper. And I always think of that when I think of the Pythagorean theorem. I think of Captain Kangaroo cutting the piece of paper to make the right angle. Okay, so that helps me remember, oh yeah, the hypotenuse is the angle that he cut. The other two sides are called the legs. This is a leg down here. I kind of got my writing in the way of it. It's important that we distinguish the hypotenuse from the legs. Which leg is which doesn't matter. For purposes of Pythagorean, we always call the legs A and B, and the hypotenuse has to be C. The very Pythagorean theorem itself is that, I like to memorize it in this form, where these two are the legs, and this is the hypotenuse. Cool, right? Simple, easy to remember, alphabetical order. We square each one of those sides and we add the two legs together and they'll equal the hypotenuse. Oh, it's so easy, it's so fun. Very often, for purposes of our algebra, we'll rearrange it and we'll write it like this. And you'll even see that often we want to solve for c, so we'll say c equals the square root of a squared plus b squared, okay? These are all just algebraic variations on this original one. So for now, you can just memorize this, write it in your book. Anything that's written in your book, you should memorize, the cover of your book. I probably should have made that point. You should know that. But I'll just tell you, memorizing formulas, yes, you have to do it. It makes life easier. These are different variations that will make your life easier in certain kinds of problems. Okay, so there, if you remember that, you'll be fine. Okay, let's put it into use. I think there are just 2 problems in this lesson. Grace is sleeping by my feet and she's growling. She must be having some kind of a rough dream. Now I'm ready to do example 10.1. It says use Pythagorean theorem to find side A. And this is the way the picture looks. And you may look at this and go, but wait, the picture we drew before, it was the other way. It doesn't matter. Okay, so we look at this and we go, okay, what's going on? Well, here's the right angle, so the opposite side is the hypotenuse. So we know that's going to be equal to C. A is already A, it's one of the legs. This is the other leg, so we'll call this one B. Okay, then we know that we're dealing with A squared plus B squared equals C squared. And now we can just plug in the values that we have. Okay, now we'll square them. Swim some plain number fish. A squared equals 33. And now for the final step, we just take the square root and we get A equals square root of 33, right? A square root cancels out a square. So those are, that's how we neutralize the square, is to take the square root of it. We have to take the square root of this. You might be asking, don't we have to do like a plus or minus thing? In geometry land, we don't, because I'll tell you what, that is not a negative number. The length of this side is not negative that. I can guarantee you that. It's got to be a positive number. And that's the right answer. So we can disregard negative roots in geometry land. Last problem. Isn't this a fun lesson? It's so fast. But it's so important. We're going to use Pythag boy so much. Use the Pythagorean theorem to find the distance between the points 4, 2, and -3, 4. All right, we're gonna have to do a little bit of graphing to make this happen. I'm gonna graph these 2 points, 1, 2, 3, 4, and then up 2, and then -3, 1, 2, 3, and up 4. So I have to find the distance between these 2 points. The way I'm gonna do that, oh, it's so exciting. I'm gonna draw, we're trying to find this distance, right? I'm gonna go down and over, because I can count the units down and I can count the units over, and then I can use Pythagorean theorem to solve for this, because I'm creating a right triangle. What? Isn't that cool? So now it's gonna be super easy. And by the way, this used to drive me crazy when I was a student. I would think, why don't you draw the triangle like this? Like that's how my brain saw it first. Spoilers, you can, right? Because for whatever number you get for this leg, it'll be the same here. And whatever number you get for this leg, it'll be the same there. So if your brain sees the triangle going that way, off the diagonal, it's fine. It'll work either way, right? So now we just look at our graph to count the units. This is 2, and this is, let's see, 1, 2, 3, 4, 5, 6, 7, going across that way. And notice it would work the same. This would be 7, and this would be 2. Okay, so now I know I'm going to call this one A and this one B. I know these are the two legs. The legs come out of the right angle, and the hypotenuse is opposite. So I'm going to call that C. That will give me that number I'm looking for, the distance between those 2 points, right? So I can do A squared plus B squared equals C squared. And this is one of those moments where I'm really looking to find the value of C, right? This is one of those moments where I could save myself a little bit of trouble if I used this form of Pythagorean. Later you can make that shortcut. For now, I'm just going to work from there and show you the long way to do it. But as soon as you start feeling ready, you can take some shortcuts and use the other versions of Pythagorean Theorem to do that. I'm just going to do it the basic way. We would have 2 squared plus 7 squared equals C squared. 4 plus 49 equals C squared. That is 53 equals C squared. And now I square root both sides, and I find that C equals the square root of 53. Again, I would have to consider positive or negative, but there's no way that this is a negative number. So I can ignore that and just choose the positive root. C equals the square root of 53. Yay, that's the right answer. Okay, so Pythagorean theorem is super useful for finding a distance between 2 points. We do it just by drawing a triangle, and that allows us to find the length of what turns out to be the hypotenuse. Okay, this is review, so hopefully you're going, oh yeah, I remember this. That would be ideal. You also may remember learning that we can never divide by 0. That's a lesson that I taught to the Algebra 1 students today. And part of their assignment is to watch the video of the kingdom imploding. I'm going to go ahead and link one of those videos to the description of this lesson as well, because you can never get too many reminders that you never divide by 0. You can't do it. It'll blow up the kingdom, and I'll put that link in so you can just have a little fun reminding that. It'll be in the description. Yay! Okay, lesson 10 is over. Thank you. Goodbye.